Okay, so in this problem we have the graph given right here. And the first thing we want to do is isolate the mass. That would be right here. So in this case we have a tension going up and then the weight going downwards. Now we know that the sum of all the forces are mass times acceleration, but in this case we know that the acceleration is 0 because the movement of these bodies at equilibrium. Now if we continue to work on this problem, if we look at the x-axis or the forces on the x-axis, we know that this side right here is in the positive direction and this one is in the negative direction. Now we know theta 2 is 30 degrees and the adjacent side is cosine. That's why we have the cosine right here for T2. And for the other one, we just subtract because of the negative. It's on the negative side. It'll be cosine of 10 degrees. That equals 0, as we explained above, because the acceleration is 0 because it's at equilibrium. Now with respect to the y direction, we have this side right here and this side. So for T2, we know that the opposite side of theta is sine. That's why we have right here we have the negative T2 sine of theta minus the T1 sine of theta 2. Why is it negative? It is negative because acceleration is going downwards, which means mg, the weight, is be positive because it's going on that direction. Now we just add up the two equations that we have, one for the x direction and one for the y direction. We just add them up and we get the following right here. Lastly, we just solve for T1, and from here we can just put in the numbers. Thus we would have 70 newtons for T1. Then we just need to find T2. Therefore, we will have 79 newtons as we plug in the values in here. Lastly, we were given that T3 was already 40 newtons. And that's how we get the problem done. T1, T2, and T3. We have to plug in the values, solve for T1, that will give us 70 and for the work. Now, if we just plug it in on the value of T2, we will end up getting 79 newtons. Similarly, we were already given the value of T3, this